Let's now focus on AutoFS and its benefits. AutoFS is an automatic file system mounting software, which is, as its name implies, automatically mounts file systems. And the file systems can be of various types, including NFS, a local file system such as ext3, NIS, Samba, etc. Now, the reason why AutoFS is useful is that there are times when you need to access a remote location through your root structure, through your directory tree, but may not have that need on an ongoing or continuous basis. So if sometimes you have the need, but not most times, then rather than wasting unnecessary system resources, consider implementing AutoFS. But there are some rules to how this unique daemon works, and we will cover them. Now, AutoFS requires that AutoFS be installed. Must be installed. And we will confirm from the shell on our NFS host server whether or not it is installed using rpm query all. This will come back momentarily. And we see that the latest version, 5.0, latest major version, is installed. An rpm query list of AutoFS returns the included items, including drivers, as well as the primary configuration file auto.master, which is located beneath etc. This is the primary configuration file. It contains pointers to other configuration files, such as auto.mis for miscellaneous mounts, net, smb, etc. There is an etc sysconfig entry which contains defaults which influence the startup environment of AutoFS. So default startup directives can be managed through this file. A less of it will reveal useful directives, including the timeout that is applied to automatically mounted file systems globally, unless you override the options on a per scope or per mount basis. So what this means, default timeout equals 300 again, is if the file system that was automatically mounted is not being used for 300 seconds or more, the file system will be unmounted. However, AutoFS will provide access to the file system if you subsequently request access. So it automatically mounts file systems upon request, which basically means any type of I/O requests. Upon I/O requests. So if you attempt to read or write to the directory that's under the auspices of AutoMount, it will automatically make that mount point available. And of course, if there's an error reaching the remote file system, you will see it on the screen and will be unable to access the file system. Whether or not the maps that are available or controlled by AutoFS are browsable, how the logging is handled, LDAP entries. This version of AutoFS supports LDAP, getting its directives from LDAP or cross-referencing LDAP for information. It ships with quite a bit of documentation and sample auto files or AutoFS files, as well as man pages, multiple levels of man pages for AutoFS, so you can learn more about the directives. With that said, let's take a look at the primary config file, auto.master, because from there we can determine the hierarchy of the configuration. We'll navigate to etc, and then less auto.master, and there are several auto files. This is the primary config file. It contains mappings or references to mount points which reference files that control the mappings beneath those mount points. So this is the primary configuration file, but it also contains mount points and their mappings. So taking a look at this config file, we see that there's a mount point for /mis or miscellaneous, which is controlled by the auto.mis file for miscellaneous, and /net, which is controlled by -hosts. Now, focusing in on this first entry for auto.mis, we can take a look at the map file to determine more information about it. The primary config file contains mount points and their mapping file. However, the mount point file itself contains additional information, including the mount point, the share, or the item that is to be made available, options such as a specific file system type, as well as the location, where to find that specific type. Whenever you access, for example, the CD entry, MIS CD, automatically the ISO 9660 file system that's related to dev CD-ROM gets mounted automatically. Here are some examples of other mount options that can be controlled through MIS. So if beneath MIS, /MIS that is, we attempt to access Linux, then it really would mount this FTP source. However, impractical. Boot would mount, let's say, your first ATAPI hard drive, floppy, and other disk types. Again, the MIS mount point is controlled by this auto.mis file. And let's also note that AutoFS must be running in order to auto mount/dismount directories. And by default, it's not set up to run, so if you attempt to access resources beneath mount points that are controlled by AutoFS, it'll fail. So again, we have a hierarchy of auto.master, which contains a list of different mount points that are governed by AutoFS. Within those mount points are mappings for items that are to be referenced beneath those mount points. So if you access /mis, /linux, or /cd, then all of a sudden another file gets called with the appropriate instructions. Super. So now our task, since you have a good sense for the hierarchy here, is to create an auto mount. So create an auto mount for /shares, which we'll create, which will mount /NFS1 and /NFS2 automatically. So to do so, we should update, first and foremost, etc auto.master. As we've mentioned, this is the primary configuration file which contains the different mount points AutoFS is responsible for. So let's nano auto.master. If you tab it out, you'll see multiple items, including MIS and NET and SMB. And somewhere in this document we'll include a comment, AutoFS for /shares, which we've yet to define, and then we'll indicate the path. Now the path doesn't need to be off the root of a file system. It can be anywhere in your file system. But we'll just follow along with the defaults, indicating /shares as the point of interest that AutoFS is to monitor. And whenever someone or a process accesses /shares, we ought to consult etc auto, or AutoFS is to consult the rules in etc auto.shares. So if a user or process tries to access /shares or anything beneath /shares, AutoFS should consult the rules defined in etc auto.shares, which means we need to define all of this. Let's make directory shares, and then let's create an entry for the auto.shares file. Now again, we have multiple auto items, such as AutoMis, auto.net. You can derive ideas from these different items. They can even be scripts, and so on. But for our intents and purposes, the useful auto items include auto.master, auto.mis, auto.net, and auto.smb. Let's copy auto.mis. We'll cp, this is a template, to auto.shares. So update etc auto.master with shares space etc auto.shares. Then copy etc auto.mis to etc auto.shares. And then the next step is to update the rules in etc auto.shares. Let's use nano to do just that. So we need to determine what is to be accessed beneath /shares, and as we've described, we'll begin by making NFS1 accessible. So let's comment out CD, leaving it in as a templated item, and indicate NFS1 as the point of interest if a user attempts to access beneath shares with a file system type of NFS. Any supported file system, any kernel supported file system can be indicated and used by AutoFS, because again, AutoFS simply monitors the I/O for a specific directory and then quickly fires off a mount request. It's just a quick way of auto-mounting or provisioning a mount for the user. So the type is NFS, and it is reachable via 192.168.75.199. So we'll line that up over here, :/NFS1. So this is our first AutoFS entry to auto-mount /shares, which will be the root level container, /NFS1, whenever we attempt to access resources in that directory. Once this works, we'll follow up by including an entry for NFS2, and then we'll get the picture. Again, we're focusing on NFS naturally because we recently wrapped up our discussion of NFS, but this applies to the other file system types such as ext2, 3, or even a remote source like FTP using anonymous connectivity or an anonymous access. So providing nothing else is uncommented that would get in the way, let's save the changes to this file auto.shares. Now again, AutoFS is currently not running. In fact, in lsl tr etc init.d in search of AutoFS reveals the name as AutoFS, which means we can use service AutoFS status to get a sense for whether or not it's running. Now it shows that AutoMount is running. So indeed, if we attempted to access the resource after having reloaded the service, it would run. Let's use checkconfig to confirm that it's set to run, and indeed it is. It's set to run in levels 3 through 5. So it is up and running. But to effect the changes for our new config file, we'll need to restart AutoFS. So create AutoFS tree, which includes /shares / and NFS1 and 2 will be auto-mounted. Next, restart the server, the AutoFS service. And then the fifth step will be to test, or the sixth step in this case, test access to AutoFS control directory. So let's restart the AutoFS service. It's being stopped. And let's echo runs the status to be sure that it's successfully restarted, and it has, which means again a PSEF grep of AutoFS will do the trick, will tell us that. Another helpful thing that we can do is to dismount the NFS1 and NFS2 shares that are currently mounted. So let's do that. So we restart the service, and let's make F to unmount /NFS1 and NFS2. It doesn't make sense to auto-mount items that are currently mounted. And as we can see, they're not mounted because this is the local system. So this step can be ignored, or will list as if necessary. Note, do not auto-mount directories that are already mounted. Avoid that headache. Avoid confusing auto-mount as well as the general kernel mounter. So with that said, we need to test access to the AutoFS control directory. A simple request would be as follows. LSL shares NFS1. Again, we have not created the NFS1 directory. but AutoFS will automatically take care of that for us. No need to do so. Let's take a look from the shell. Notice the items are available. These are the files that we're currently exporting. That means if we lsltr shares, we'll find NFS1, and we did not create this directory. Let's see if the same works for NFS2. The first time we have attempted, it's thrown an error. The second and third, so this tells us that it's not going to auto-mount. Why is that? Well, if we count the contents of auto.shares, you'll see why. The only item that is to be auto-mounted is NFS1. So, let's continue by adding a mount for NFS2, now that we know that NFS1 works. Also, if you execute a mount and then grep NFS1, you'll see that it's auto-mounted. It's available. The kernel isn't going to differentiate between the auto-mounted file system and a normally mounted file system in terms of whether or not it displays it via mount. The major difference is that AutoFS has functionality or control over the mount point that standard mounting does not provide, such as the ability to kill the mount if it's not being used. Let's nano auto.shares again, and we'll create a duplicate entry or seemingly duplicate entry or close to duplicate entry for NFS2, and then this mount point will become available momentarily. Let's service AutoFS reload, and then the maps have been reloaded without restarting the service. So now let's try to access shares NFS2. First time fails, second time succeeds. And again, we can interact with any of the documents there. Let's take a look at the security policy file. It's really a text file. And again, it's available. And we see the two types. Now, if enough time elapses, the mount points will be automatically removed. If you want to see the changes take effect sooner, in your production environment, modify etc sysconfig AutoFS. Change the default timeout to something more reasonable, perhaps 30 seconds, and then restart the service. Execute mount after it's restarted, just to be sure that the mount points are not in your table, and then try to access a mount point, such as shares NFS1. The first time throws an error, the second time does not. Now you simply let the clock tick, as the AutoFS service will keep track of whether or not the resource is being accessed. When you launch AutoMount via the AutoFS service, it shows up in your process table as simply AutoMount. So again, while we wait the clock out, the primary feature provided by AutoFS is the ability to automatically mount file systems using a variety of supported file systems, NFS, Samba, local, you name it. It does so by listening for I/O requests, input, output, reads, writes, and when it senses those requests, it automatically makes the mount point available. It may throw an error initially, but most well-tuned applications will know to retry until a certain timeout before giving up. The AutoFS RPM must be installed. The service must be set to start up when the system reboots in the event that you're going to use it in production. The default options in etc sysconfig AutoFS, including the default timeout and options pertaining to LDAP. There's a primary config file where you'll place your mount points. That's etc auto.master. It will reference your mount point file, such as auto.shares that we've created. Inside of auto.shares, you follow a simple syntax for publishing your shares. The syntax is very simple. It's basically the mount point, any options, and the location. So note, syntax for auto mount files is as follows. And the documentation, of course, has this information. The mount point, which is required, where in the file system to mount it. Doesn't need to be at the root of the file system. Optionally, any sets of options that should be included. such as file system equals and the type of file system. Generally, the kernel, the Linux kernel that is, can tell the type of file system and consequently doesn't require it. And you must indicate the location. So case in point, NFS1, optionally fs equals, or fs type equals NFS, and it's prefixed with a hyphen, followed by mandatorily the path to the NFS share. And this is your entry. This means whenever someone or a user or process attempts to access /shows/NFS1, AutoMount will carry out this NFS mount. And ditto for other types of mounts, such as Samba. Simply follow the syntax for mounting those file systems, and AutoFS will take care of the rest. Now let's take a look at our mount table after we've burned a good amount of time, and notice NFS1 is nowhere to be found in the mount table. We'll grep NFS1, it's gone, because AutoFS has done its job. But again, if we attempt to access shares NFS1, it'll work on the second try, of course. Ditto for 2, and so on. And we can configure this AutoFS feature set on any of the Red Hat Enterprise systems or any Linux system that runs the software. And if you can't find the package for your distribution of Linux, download the sources from online, but most of the modern distros includes it, and you should have no problems running it. So that's the main way about AutoFS. It's not terribly complicated. It just provides a means for auto-mounting, auto-provisioning file systems for temporary usage, which consequently frees up resources for other tasks, whereas what we showed you with NFS runs indefinitely until the system either exits the run level to a non-multi-user run level or is shut entirely.